All right, good evening, everyone. Welcome to the live chat for November 30th, 2022, the last day of fall, meteorological fall. Tomorrow we start meteorological spring. It's not spring, winter. Spring, what the hell? Yeah, what the... yeah, as you could probably tell, we have been very busy this evening as it seems like the rest of the meteorological community has recognized that this pattern is not going to be your traditional La Nina. It's going to be very interesting to see how everything's going to evolve, but one thing is for sure. The pattern we are seeing, that we are starting to see evolve here, we have not seen since 2009, since 1995. Those are the two Decembers that matches closely to what I'm seeing now. Not just in the look of the 500 millibar pattern, because everyone takes a look at the 500 millibar pattern and then they say, well, it looks like these years. What I decided to do is I went back and I looked at the forcing mechanisms of the patterns that matches the one that's developing. And I matched the end zone years and the sea surface temperatures, much like what we did with the winter forecast. And the evolution and the forcing mechanisms that are setting up this pattern. And I do apologize for, I noticed a little bit of dust kicked up because we're decorating the entire apartment and stuff. It'll be all right. Yeah, pretty much. But if I seem a little bit excited this evening, it's because the theory that I put out there in the winter forecast, that with complete honesty, I had very little confidence in how well it was going to work out because it's something that we've never seen before, appears to be working. So tonight I'm going to show you that evolution and what I'm seeing in the forcing mechanisms that are driving this pattern and why that's important and what that means for the rest of the winter. Before we get to that, let's take a look at some of the current observations. And it's pretty windy out there. I believe that they're starting the Rockefeller tree lighting, all that stuff this evening. And it's going to be a bit breezy out there. The cold front is moving through the region. Temperatures are falling off rapidly, about a 10-degree thermal gradient over the region this evening, with winds as a result ranging anywhere from 10 to 20 miles per hour sustained, gusts pushing up to about 30-35 miles per hour at times. It's going to be a bit chilly out there when you're watching this tree. It's going to only get colder as the evening goes on, as your temperatures continue to fall, and they'll eventually fall into the 30s. Some pretty impressive cold air transports taking shape here. Taking a look at the SKU-T chart here, you can see the cold air coming in. There's a classic cold air transport signal. I think this might be a data point error, but you kind of get the idea here of the cold air coming in, and because of that cold air coming in, you're allowing this mixing to take place and taking this stronger winds, mixing them down towards the surface, and leading to, and at times, some pretty good gusts over 35 miles per hour. Earlier on this afternoon with the heavier rainfall, we did have support for some of those wind gusts pushing up to 50 miles per hour, as we've been warning for the past couple of days. It looks like that verified, unfortunately, and a couple of Christmas and Hanukkah holiday stuff went flying down the street in some locations. So it's definitely been a rather stormy day, but now the cold air is coming in, and with it, the dry air is coming in to clear everything out. And we see that very nicely on the radar and surface map here from WeatherTap, and even more impressively on the water vapor satellite picture. Look at this enhanced upper level low that is starting to set up this whole pattern. And the reason why I really focused in on this cold front is that this is the synoptic kickstarter, the synoptic trigger to get this whole pattern evolving. Okay, because right now we're transporting warm air warm tropical air into the polar regions as this upper level low develops. Right now, sure, we're mild. That is going to change in a big way as we move forward, as more cold air gets pushed south into the region. So we know over the next couple of days, more tranquil weather conditions will be building in, scattered cloud cover, and we have a couple more cold fronts on the move, and then we transition into our weather pattern. But before I touch on what the potential is for the middle of this month and beyond, it's important to understand what's happening right now, what's forcing this, so that way we have a better idea of what is more likely in the model guidance, right? Because if we just jump to let's look at the models, then you can't pick up the error and you can't pick up some of the factors that sometimes leads to high latitude blocking breaking down faster or slower depending on the evolution of the pattern. So for some of you guys who are new, I'm just going to go over this real fast. There's some of you guys who have been here and watched this channel, we've been going over what to expect with this winter weather pattern for the past couple of weeks. Stay with me here. I'm just going to kind of go over the primary factor that makes this season so unique and very interesting. Of course, let me just touch on the sea surface temperatures here. Once again, east-based La Nina, and this is what you typically see talked about in a lot of your publications about the winter. They either talk about El Nino, La Nina, or La Nada, which is nothing, right? And the focus is primarily just on that. Problem with that is that the atmosphere is far more complicated than just saying La Nina, copy, paste, print. Okay? If it was that easy, seasonal forecasting would be so incredibly easy to do that everyone would trust it. So in this case, what we have is an east-based La Nina. Now we know it's east-based because the coldest anomalies are towards the east. And we have a warm northern Pacific. And there are very few years that matches this type of sea surface temperature anomalies. Okay, so we could cut out a whole bunch of years and go straight to that. We also know that we have a weak polar vortex. So weak polar vortex plus this type of signature in the Pacific narrows it down to one specific year during the most recent patterns. And I want to stay as recent as possible because it influences with climate change. And that would be 95, 96. You could use 2009, 2010, but I don't like using that one as a direct connection, only because the evolution of the polar vortex, the way it got weakened, is different than what we're dealing with here. So that deals with the sea surface temperature anomalies and what's driving this. And if we weren't dealing with a weak polar vortex, you would end up with a traditional east-based La Nina with a ridge axis, basically what we're seeing right now, right around the Bahamas, and your polar jet stream dipping in the plains and your storm track heading towards the Great Lakes, right? That would traditionally be a mild weather pattern for the eastern United States, but every so often you get some cold air coming in and you could end up with some wintry mixed storms, kind of like what we saw last year. That was the theme last year. We went into the winter saying, hey, look, it's going to be east-based La Nina. The ridge is going to be off the east coast, but when we get the high latitude blocking, we'll get some storms that could lead to some snow and wintry mix on the coast and whatnot. So if you just go based on the tropical forcing and that's it, there's your winter forecast. But we knew that that wasn't as simple because of the volcanic eruption back in last January. Now, let me segue for a second. I know that we have a volcano that has just gone off in Hawaii. Let me be very clear about this. Unless that volcano absolutely blows up, then it's not going to have an impact on this winter. Because there's a lag time between the dispersion of the soot and the rocks and the different gases coming out of this volcano compared to the previous one. And that lag time would suggest an impact on climate depending on how long it goes and how, if it ends up being any stronger. At least not until the spring, maybe the summer, somewhere in that ballpark. Not a direct impact on this winter. It's certainly going to be something interesting to watch, and another factor to consider with other long-range forecasts as we look at spring, summer, and beyond for next year. But for this winter, unless this volcano goes supernova, and you're talking about like a supervolcano eruption, which there's no support of that happening, there's no direct impact for this winter, mostly because of the lag time factors here. So, with that being the case, let's talk about the influence of our previous volcano, which happened around Indonesia and sent a ton of water vapor into the atmosphere. Well, some of you that are new here, the basic idea here, if I could pull up the right data, let's see, here it is, okay, is this. A lot of water vapor, 10% above normal, got thrown into the atmosphere, right? You might have heard about that. What that did is that it disrupted the entire evolution of the stratosphere. And this has not happened before in recorded times. I can't say never, because we don't know that, but in terms of recorded data, we've never experienced this before. So, what that did is that it threw up a ton of moisture into the stratosphere, but at one particular level. And that level was at 30 to 50 millibars, around 25 south to 65 south. Now, what that is, that's the southern hemisphere, the mid-latitudes of the southern hemisphere. And this is why I know some of you guys, we already went through this, but I want you to understand why this is so important. The impacts of that volcano led to cooling of the stratosphere at that particular level, but only at that particular level. Okay, this is record cold temperatures in the mid-levels in the southern hemisphere between 30 and 50 millibars. If we go to 10 millibars, we're slightly below normal, but overall we've seen a moderation or trend back towards near normal, where we haven't seen that at other levels. And you go higher up in the atmosphere, say to 1 millibar, it's even closer. Why is that important? Well, it explains the forcing mechanisms. Because remember, the atmosphere is always looking to be in balance. So, if you have a stronger imbalance at 50 millibars on down, you're going to see more disruption 50 millibars on down. Now, let me take you to the next feature, which is our vortex. This is the polar vortex via the GFS. You can go to stratobserve.com and you can use this data. I think I've saved it on my... I'll have to save it on Twitter just to post it, but it's an easy website to find. It's great research data, and basically this is the GFS. Now, notice above 50 millibars, 30 to 10 millibars in this case, the polar vortex is pretty strong. And we also see that here. This is Earth News School. This is a strong polar vortex at 10 millibars. Look at 70 millibars. Completely different, disrupted, splitting. It's not uniform. We see that here as well. Down here, it's split, almost like pants, right? In fact, here, you can see the evolution. This is strong overall. This is getting split into two. So what's happening here? And why is it important to our discussion as we move forward with the rest of this winter? Okay. The atmosphere is trying to work out all of this above normal water vapor in the lower to mid stratosphere. It doesn't have to do that in the upper stratosphere. So the upper stratosphere is basically acting like you would normally expect with the active solar activity and a La Nina pattern, i.e. a strong polar vortex. But that's at 10 millibars. From 50 millibars on down into the troposphere where we are, we see a continued disruption of the polar vortex. And we're seeing that because of that imbalance. Now notice, let me go back to, if I could find it, there it is. Here it is. Okay, so notice when we go to the northern hemisphere, we start to see, again, the mid-levels, support for some slight cooling, but then we go to the high latitudes where we watch to see whether or not we're going to see our developing high latitude blocking, spikes of above normal temperatures in the stratosphere. Stratospheric warming. Want me to take it a step further? Okay, how about this? Let me see. Here it is. I'm doing good today. Here we are. This is 10 millibars. This is the temperatures are 10 millibars. Most of our warming at the mid-stratospheric levels, 50 millibars, has been focused over North America and portions of Asia. We're now seeing that warming starting to push up to the higher portions of the stratosphere. So what does all this mean? It means that we're developing a feedback mechanism. And the models are starting to catch up to that mechanism. So, you have a favorable sea surface temperature anomalies. You have a clear, persistent disruption of the polar vortex from 50 millibars on down because of all of the above normal precipitable, water vapor in the mid-stratospheric levels. And that factor is leading to a constant punching of the polar vortex. And that was the whole theme of the winter forecast. That, hey, of all the factors that we're studying, of everything we always look at, this factor here, that volcanic influence there, was going to be the factor that drives our high latitude blocking regime and won't let it go. And we started to see it all through the fall. And now, well, ladies and gentlemen, here we go. 50 millibars, splitting of the polar vortex. When it tries to come together, it gets warped. The GFS is finally starting to catch on to that idea. It splits it. When it does try to come together, it gets warped. So we never get a strong polar vortex. Either it gets stretched and pulled and constantly disrupted, or it gets split in half. And what that tells us, especially when we see this signal here, see this faint signal here? Again, we're 15 days out, so these signals get very faint. But what you generally get here is the ability for the polar vortex to continue to get stretched, split, and drive high latitude blocking that leads to this. And that, ladies and gentlemen, sets us up for our winter storms. So now you understand what's causing this. It's not the models are having a holiday. It's not the GFS is winning. I see a lot of people always say, well, the models don't cause the weather. The models just try to pick up on the current observations and try to transfer that forward via physical equations and calculus. Okay? If you got bad data in, you get bad data out. If you understand the forcing mechanisms, then you use the models only as a tool, not as a crystal ball. So, what we know is the driving mechanisms are in place. They have been in place. We've been testing them all fall, and now they're coming to maturity. And now as they're coming to maturity, here is the next question. As we get this block, and as we start to get better understanding of the interaction between the subtropical jet stream and the polar jet stream, what I mean by that is this jet stream and this jet stream. Okay, we'll go to another feature here. We'll do 250 millibars. The clash between this jet stream and this jet stream. This brings the moisture, this brings the cold air, and when they come together, I lose more hair. Okay? So, the question comes down to then, with each winter storm that we're going to start seeing starting in mid-December, how does that feed back into the overall pattern and leads to the next storm and the next storm? And as we get that evolution to take place, how does it look when we start to see a relaxation and then re-amplification? Because other than the winter where we had no summer, which happened to be in the 1800s with a supervolcano, you're going to have a relaxation and a thaw in January. It happens every year, regardless of what's going on in the winter. The question, though, becomes with this type of environment in place, is this a 1 week thaw or less? In other words, this pattern is going to remain amplified. So when we see all this data come into play here, and then you start to see this signal start to show up, well, let me tell you why a lot of meteorologists are kind of pausing and saying, wow. Okay, in this pattern, the reason why it catches everyone's eye is because, of course, you got your high latitude blocking here, and you have your true negative NAO pattern. You also have a 50-50 low or 50-50 trough. That's when you have a trough or an upper level low right around 50 north, 50 west. That's a perfect location to support slowing down of a low pressure system on the east coast and keeping cold air in the coastal plain. Okay, so you have that signal. But what really caught my eye and a few other meteorologists out there on Twitter is this signal right here. If this signal, this ridge axis, remains in place once we get under 10 days and under 5 days, that is a very strong signal for a winter storm, snow-producing storm for much of the mid-Atlantic. And the reason why is because of trough and ridge dynamics. Okay? When you get a ridge axis right around Montana and Idaho, and you can read about this in several research papers, but it's really analyzed really nicely in the Costa Mussolini Northeast Snowstorms book, which of course is a staple for anyone who's studying meteorology. If you're looking for a great book for the holidays, that is a book I strongly suggest getting. It was like the best Christmas ever when I got it. That book really does a great job of breaking down the signals for a major winter storm. And in this case, when you get a ridge axis right around here, what that does is that it forces your trough axis to set up between the Mississippi River Valley and the Tennessee River Valley. And what that leads to is the perfect amplification of the trough along the East Coast and the support of a storm track over the coastal waters. It can't track inland, it can't track out to the sea, it gets locked right into the coastal waters. And that leads to a very high potential when you combine that with this feature here for a major winter storm. And this signal is very much similar to a lot of impressive December winter storms. Now, with me saying that, please understand, I do not know the details. I do not know the specific storm track, timing, who gets what, when, and why. That is way too far out. And I'm warning you, you're going to see a whole bunch of different phantom storms and, model swings from no storm to the storm cut up into Albany, then the storm is out towards Bermuda, and then it's a perfect storm with 14 feet of snow in New York City, and then no snow the next run. Complete model chaos. Cats and dogs living together and ghosts showing up. Going to be nuts. So don't get wrapped up into every individual model guidance. And do not trust anyone that throws out a snow map on any of this stuff until we get under 120 hours. Because I am telling you right now, with everything going on with the pattern changing and the limitation of collecting all the data that we need to study with these individual shortwaves coming in from the Pacific and from northern Canada, you're going to see just a wild swing in these models. That includes the European, the GFS, and all the ensembles, and any other model you can think of, from the UK Met to the Korean to, I don't know, I think some people are now using a Brazilian model or whatever. It's not going to matter. Because of our limitation of data collection, expect wild swings in the model data and expect a lot of uncertainty. But what I can tell you tonight with confidence is that the potential for a significant winter weather event is growing rapidly for the middle of this month, for the middle of December. And that potential, if this forecast of this ridge 10 days out verifies, we're in for a lot of interesting times ahead. So now that I did my rant and we went over everything that I've been thinking about the past couple of days, I'm going to go in, I'm going to answer all your questions. I'm betting that YouTube is active, I see, and I see that our community chat and premium chat is active as well. So let's dive in and answer some of these questions, and we'll do that the rest of the night. Let's see here. A lot of activity too. Thank you everyone for visiting. That's really awesome. All right, so first we have first question from Card. The stratospheric polar vortex at 10 millibars still has that big tropical feed, and 70 millibars is all over the place. Yes, the polar vortex at 10 millibars is pulling in a lot of different feeds coming in, not just from the Arctic, but from the tropics as well. It's almost like it is the polar opposite of what 50 millibars on down is. 50 millibars on down is completely disrupted and torn apart. But above that, it's a very strong polar vortex, almost historically strong in its strength. The evolution of the warmer air pushing northward, or should I say upward, in the atmosphere around the Pacific should have some interesting impacts. I'm not sure whether we'll see a drastic weakening, probably not, but I think that the 10 millibars is going to remain relatively strong. 70 millibars, though, definitely severely disrupted and driving this whole pattern. Will the eruption of Mauna Loa volcano in Hawaii have any effect on the weather? Not immediately, but we'll have to keep an eye on it to see what impacts it has in the spring. Could lead to a little bit more of a prolonged winter, i.e. a cold March, and then a unsettled spring, but I'm not sure yet. A lot of the eruption thus far is pretty much lava and soot that's basically well below the stratospheric levels. What you need is an eruption that pushes into the stratospheric levels to really have a impact globally. Right now, it's only an impact locally. Let's see here. Joshua asks, do you good storm potential for eastern Great Lakes this winter? Okay, I think I understand what you're saying. I think the eastern Great Lakes, and we talked about this before, Joshua, pretty much focused on lake effect snow impacts. This pattern, I think, is more focused to the east of you. Now, that doesn't mean that the Great Lakes won't see snow, won't see impressive storms or anything of that nature. But if you're talking about the overall storm track, I think the primary impact of snowfall around the eastern Great Lakes will be driven by lake effect snow and Alberta clippers. It might be that time to take that trick-or-treat sign down. Never. I'm going to keep that up.
No, that stays.
Yeah, that stays. So we have like Christmas and Halloween all mixed up in here. And it's...
And Godzilla.
And Godzilla and pretty much everything else. We got a lot going on here. Again, our wedding was Nightmare Before Christmas, if that gives you an idea.
Nightmare Before Christmas.
Well, it was a mix, but kind of. It was kind of driven on that. We couldn't get everything, but it was a good mix on that. Let's see here. 250 millibars has interesting feature, long jet streak that starts north of the equator, near area north of East Indonesia, dips into the southern hemisphere due south of Alaska, and then back into the northern hemisphere above about due south of Baja California. Don't recall seeing anything like that before. Let's take a look at it. Let's see here. Let's be talking about this feature right here. Okay, what I will say about this jet stream, with the subtropical jet stream, again with La Nina, is that this is extremely unusually amplified for a La Nina influence. The subtropical jet stream is just amplified to the point that it's almost El Nino-like in a way. It's very unusual this year. Normally in a La Nina season, you'll get more of a benign jet streak, and then you get this ridge here, which we still have the ridge. This right here is a clear driving factor for La Nina. But the rest of this is not. So it's almost like as if the southeast ridge is getting completely crushed out of this entire scenario. It's trying to fight back, but it really doesn't have any legs. And so you can just see the polar jet stream and the influence here just crushing the influence of the southeast ridge this year. And this whole amplification in the subtropical jet stream is one that is just very impressive. And you know what's unusual this time is this feature right here to the southwest of Hawaii. This area of diffluence and divergence. It's like, kind of like you have this convergence here, and then divergence and diffluence is very strong here. And the reason why this catches my eye is because this is right around where I look for convection. And let me see, which one is it? This right here. That area of divergence and diffluence is right about here. Now, the reason why that catches my eye is this. We know based on research that when we start to see convection, and we saw earlier on and we're starting to see it firing up again, when you start to see convection refiring up in this range, this is when we start to see a lot of winter storm activity supported for the East Coast. So as we get to the middle of December, I will be watching very carefully to see whether or not we start to see convection firing back up here again. Now, the last time we saw convection firing up here, we had a major rainstorm move through the region with pretty strong East Coast cyclogenesis. So this is going to catch my eye because as this convection sets up and it falls under this influence of divergence and diffluence, do we see even more enhancement, even more latent heat release, which leads to a further enhancement of the polar jet stream and amplification of our Pacific pattern into North America. A lot of interesting stuff going on. Okay, we touched on the volcano in Hawaii. Huge upper level, 250 millibar, ridge. Upper level low. around Siberia. Deep trough south of Bering Strait, and another due south of Greenland. Yeah, so basically the overall theme here, card, is that the polar jet stream is significantly amplified. Yeah. Let's see here. Saw that we are down to 2 sunspots facing the Earth. Yeah, but overall, let me see here. I know I kept it up here. Here we are. We're down to 2 sunspots, but it's been more active recently. So the sun is kind of getting quite a little bit more down. We got another month to go, and then we have 2022 in the books. But for the most part, we've only had one quiet day, one day of blank sun. Overall, this has been a pretty active year in terms of solar activity. Been a while since the Indian Ocean has been on the cool side. Let's take a look at that. And overall, yeah, it's definitely much cooler than what we have been seeing. It's starting to warm up a little bit, but nothing too significant. Let's see. I've always that the volcanoes in Hawaii had more lava and a little ash and not a huge eruption. Yeah, typically, I mean, Hawaii is mostly known as volcanoes with the ability to expand islands. In fact, all of Hawaii is based off of volcanic activity. So normally you don't see a massive explosion out of these volcanoes. 10 millibars may be strong, but it is very warped with a good feed from the tropics. It's somewhat warped. I've seen it more disrupted than what we have seen, and honestly, it's pretty strong compared to the rest of the stratospheric environment. It was not too long ago that we had a winter where there was minimal blocking, but that western ridge was so perfect, kept getting snowstorms to the coast in the northern mid-Atlantic simply because it put the east trough in a perfect position. Yes, that can happen. Now, in those winters, because of the lack of high latitude blocking, every one of those storms was a fast-moving storm, basically 6 hours or less. When you have this type of blocking regime sets up, you end up with winter storms that move very slowly, and you get to see the whole pivot factor and storms that last 6, 10, 12 hours that could pile up a lot of precipitation. Notice I say precipitation because it doesn't always mean snow. Sometimes it means sleet. Sometimes it means rain. So I don't want to just say snow, snow, snow. And then some of you guys will say around Belmar, Long Island, whatnot. And some of these storms don't end up with that type of scenario. So the key word here is precipitation. Because I'm not going to get caught with saying, hey, you said these storms are going to produce hours and hours of snow. Because I know someone's going to say that. I'm not saying that. But I am saying that these storms are more likely to move much slower than in a pattern without the high latitude blocking, and they just kind of book and move. So is this mid-December potential a one-off, or are we going to see a recurring pattern and a storm every week, every couple? What is your thoughts on how many snowstorms we have the potential of seeing? Like how many hurricanes? Okay, this is very location dependent because I know that some people don't consider winter storms as if it's rain, even though they are. This type of blocking regime, historically, climatologically speaking, if everything comes together, i.e. you get that ridge axis and you get the first storm to lock in, typically leads to at least 2 to 4 more other winter storms that follow it. That doesn't always mean you get the same impacts. Like, for example, the first one could lead to all snow event, and then the next 2 a wintry mix, or vice versa. Okay, that all depends on the individual storms and interactions and position of ridges and whatnot. But the type of pattern usually leads to a feedback process. And the reason why I put the caveat that the forecast 10 days out at 500 millibars, this ridge that shows up, this has to verify. The reason why this has to verify is because a ridge of this type of magnitude and I don't mean it has to be like verbatim, but it has to come close to this type of scenario. That type of ridge does not just disappear. It lingers. It festers like an infection in the atmosphere. All right? So it doesn't just collapse. It stays in place. And it has to get worn down. And so what that leads to is a negative NAO that maxes out in December and then slowly weakens through January and February. And what that leads to is a storm track constantly moving through the northern mid-Atlantic and the mid-Atlantic coastal waters. So that is why the initial ridge, the initial block is so important. You get this set up 10 days from now, then that sets up your whole feedback pattern. Okay? And, excuse me. And that leads to the potential for constant winter storms starting to develop. And what you want to see as this takes place is that weakening North Atlantic oscillation, because then what happens is that your storm tracks start to line up and lock in. What I would call it sometimes is kind of a seasonal atmospheric memory in a way. We've seen this before in other winters where once you get the first couple of storms locked in, then you start to get this snow moisture gradient locked in, and that's where the strongest frontogenesis starts to evolve. Excuse me. And that's where we start to get this evolution. So as far as the number of storms, if we get this block locked in, then I really like 4+ winter storms for this year. Major storms. If we get the block locked in. I am not going anywhere near 95, 96 with 17 storms. Because again, that was just... that was a perfect scenario. And again, I cannot forecast that. Because that was a freak year that we haven't seen since. But remember, the difference between a bad winter, which is one winter storm or less, and a historic winter, which is basically 3+ winter storms, doesn't take much. It just means it's just a matter of whether or not you get your high latitude blocking locked in. This one definitely has that potential. Is the net effect of the remnant southeast ridge simply to enhance blocking by preventing out-to-sea scenarios off the southeast coast? That's a great question. The evolution of the southeast ridge plays into two parts. It helps to transport warm conditions from the tropics towards the mid-latitudes and towards the polar regions, which leads to enhancement of the block. That's not a direct impact. It's a transition of air masses from the troposphere to the stratospheric level, and kind of think of the ridge as a ramp. If you're a skateboarder, you have a ramp, and that air mass takes it off the ramp and starts to get transported into the polar regions. The southeast ridge also can be a situation where it gets displaced towards the Gulf, and then it helps to enhance the ridge in the west because the above normal heights and the mass difference gets pushed towards the west coast. So it kind of gets split and then redevelops again. What made winter 93-94 so cold and stormy? It wasn't similar to this. That was an El Nino. I believe, yeah, it was a weak El Nino and a polar vortex that got disrupted in January. So not the same in any way, shape, or form. The number of storms that winter that dumped a foot of snow was much higher than normal as well. Such a unique year. Yeah, absolutely. Well, let's drop in on YouTube and see. Oh, I see that. I see that some people just need to get a new hobby. Let's see here. Let's see. Mark X is a good evening. Will the second half of December be more snowy than the first half? Absolutely. Yes. Yes. I don't know how much, but yes. This one brings moisture. This one brings the cold air. And when they come together, I lose more hair. That's very true. Yeah. Hey, Steve. Always love watching your videos. The pattern you have up, wouldn't it be too suppressed? Great question. Okay. I was waiting for that. Let's see. Vitality Golden. I think that I'm probably mispronouncing that completely. That's a great question. Okay. In this scenario, can this lead to a suppression of storms? The answer is yes, which is why the ridge axis during this time period is so key. Because what can happen is that the NAO becomes so powerful that it crushes the ridge, suppresses the ridge, and you get more of a zonal pattern and forces everything out to sea. So that's why this ridge is so important. So if you get this ridge axis, it amplifies the trough over the eastern United States and prevents that from happening, prevents the suppression. And what you end up with then, as a result, because of the pattern evolution, because of the wavelengths involved in the pattern, that it sets up storms to move over the coastal waters rather than kicked out into the Atlantic. As we go on through the season, as this ridge starts to weaken and degrade, that potential for suppression starts to go away. And that's when you start to lock in even higher potential for winter storms. For snow lovers, I always say you don't want a historically negative NAO all winter long, because all you get then is cold and dry weather. What you want is a strong block to start off in December, and then a steady weakening through January and February. Or you get a moderate and negative NAO in January, and then a gradual weakening. Because what that leads to is that the majority of your winter storms that you have historically have occurred when the NAO is in a weak to moderate negative state. When it's at that level, that's when you see most of your winter storms. Do you believe that we could see more than one snow? Well, I think I already answered that. What are the chances of blocking locks in for us? And how is February and January looking? I think I already answered the January-February idea. Of the years in which you had this type of pattern in December, and then you lost your high latitude blocking, those years featured a strong La Nina or El Nino. Either one. And what that did is that it overwhelmed the high latitude blocking and broke it down. In this case, we do not have that. In this case, we have a weakening La Nina that's starting to weaken. It's moderate right now. It's starting to weaken. It's moving towards that. And as a result, it's starting to come apart. So we don't have that scenario in place right now. So it looks pretty favorable for a sustained high latitude blocking regime and the support for re-intensification. Would you expect a tripole in the Atlantic with warm, cold, warm sea surface temperature to set up? Well, we kind of starting to see that evolve here. Warm, cold, warm, cold. So we're starting to see that start to take shape. I'm always interested to see what type of impacts the Gulf Stream has on this entire pattern, because the Gulf Stream is set up where it just has nitroglycerin for these low pressure systems. Look, if you get an Arctic air mass slam into the mid-Atlantic coast and it interacts with the Gulf Stream with very warm waters, you just set up a very powerful thermal gradient, and that could really amplify storms. So it's going to be interesting to watch how that sets up. If you can explain, how does a coastal low pivot itself under a block, and does that pivot create more phonogenesis? That's a long discussion, and honestly, I think it would be better to go over that when we actually have a storm so that we could see it. But basically what happens, the best way to think of it is this. Let's say that you have a traffic jam sets up, and you want to get out of there. The cops are redirecting you to turn around. So because the car cannot go slamming into everyone else that's in front of them, they have to slow down, and then they have to pivot their car so they can turn around. That's essentially what's happening with your winter storms. That they run into this log jam, they slow down, they stall, they do a quick turn until they find an area of weakness so they can exit out. But I think that we'll explain that better when we actually have a storm, and we can go over that more with the actual observations. If you were to build a dream teleconnection for a snowy winter, how close is this current pattern? Quite honestly, it's pretty damn close. I am very much impressed with this pattern and the potential that lies in it. But remember, as we always say in physics, you got plenty of potential, but it doesn't matter until it gets to kinetic. We have to see this whole system, this whole pattern evolve. But right now, the model data and the observations has a lot of potential. Now we'll see whether or not we can get to the kinetic portion of this, where we start to get one storm and then feedback, more after more coming in. It seems like La Nina is holding on strong. Not really. La Nina has been steadily weakening, and the key factor to look at is really your SOI values. A lot of people look at the sea surface temperatures, but those can be very volatile. Remember, the sea surface temperatures are driven by pressure and wind. So if you want to understand what's happening to La Nina, you want to understand the driving mechanisms. It isn't the sea surface temperatures. The sea surface temperatures are the result of the wind pattern developing, not the other way around. So, in this scenario, what you have here is signals of your La Nina steadily starting to weaken. Now, as I was saying, going back to the fall, this La Nina is not going to collapse. It's going to gradually weaken. And all of the model guidance for months now has been saying that December will feature a steadily weakening La Nina. And we're starting to see that data take shape. And when we take a look at the sea surface temperature trends, you're seeing a gradual beginning of a weakening of that showing up. We're no longer all into deep negative numbers. We're all starting to evolve closer and closer towards that negative 0.5 value, which is the threshold for La Nina. So we're starting to see those changes take place. In fact, if we look at the sea surface temperature change over the past 7 days, you can start to see warming clearly starting to show up here more and more often, right where the heart of La Nina takes place. Let's see here. Do we have a better chance of White Christmas? Certainly a better chance than we have been seeing. Which are your favorite? Which are favored this winter? Miller A or Miller B? That's a good one. I would say I say a mix, depending on the interaction between the two jet streams. I can hear how impressed you truly are by this. We'll see. Everyone is comparing this to 2009-10, and especially 2010-11. Yeah, I don't know why. I'm certainly not. If they're comparing 2009-2010 or 2010-2011, they're doing so mostly because they're saying, look at this chart on the negative NAO and look at this chart that we have now. And what they're not doing is looking at the forcing mechanisms. I understand why they're doing it, but well, especially 2010 and 11, it's not even the same Enso forcing. And 2009, 2010, it's not the same forcing in terms of the polar vortex. So, in terms of forcing mechanisms, both those years are invalid. In terms of, hey, this chart looks the same as that chart, yeah, I get it. But I wouldn't use those years for forcing mechanism aspects. Will you expect to go into La Nada by the second half of winter? No. I would say weak La Nina. I wouldn't expect us to have a neutral environment until the spring. Weird how weather can follow history. Yeah, it does. Back to our chat room here, premium chat room. Let's see here. There's a lot of great questions once again. Great job, guys. Absolutely outstanding. Winter done. Overall, it seems that the northern hemisphere as a whole is colder at 850 millibars and 700 millibars than it has been in recent years. Yeah, I would agree with that. Here, let me pull up. So this is going to be cool. Let's see, 850 millibars, temperatures. Now, this is 850 millibars, and this is all of the northern hemisphere. North America's here, Asia's here, and look at the expansion of the polar and Arctic air masses. And more impressively, look at the potential that we have here. We have our Arctic air masses. Now let's go to 500 millibars. And here goes your setup for your cross-polar flow from Siberia into North America. Right here. When you get that signal showing up, a lot of interesting things can start to take shape. So, yeah, there's plenty of cold air to work with. Does this winter have the potential of a storm like 78, 93, or 96? Don't know yet. I always stay away from making declarations of comparisons of historic storms because you have to understand that those storms, everything had to work out just right. And I don't like making those declarations because I have too much respect with how difficult it is to get all those conditions to come together. Do you see potential for cross-polar flow? Yep, just talked about that. Sure do. You mentioned the potential 4+ major winter storms if everything works out right. Are these types of storms that could dump 2 feet in an area, i.e. northern New Jersey? That's, you know what? I will say this. With precipitate water values running high because of global warming factors, and you got this pattern set up, and you have an increased potential for a lot more convective snowfall in these storms because of those factors, yeah, I could see that to being an issue. I mean, I don't know when, I don't know where, but I could see that potential showing up. Let's see. Joshua, I live in Northeast Ohio. Can this winter bring a long stretch of very cold winter? If I'm looking for a cold winter in the northern Mid-Atlantic, obviously to the west, you're in Ohio. As I've been saying for a couple of times, Joshua, the Great Lakes are going to see a cold winter and a very active one in terms of lake effect snow. How long can the Hunga Tonga volcano eruption continue to be a factor in the weather? That's a great question because we're such an unknown. I would say it's still a factor through the spring. I don't know whether that lasts into the summer. We'll see how fast that this moisture pool degrades. It's going to take some time. I can tell you that. I don't know how long though, honestly. And a lot of scientists, much smarter than me, don't know either because we've never had a scenario like this before. And let's see here. When was the last year we had 2 feet plus snowstorm in the Ocean County area? Oh, I don't know. That's been a while. Well, now that I think about it. I don't know. It wasn't last winter, but maybe the winter before. I think we had something similar to that. I don't remember off the top of my head though. But when it comes to snowstorms with 2 feet plus, never underestimate the impacts of convective snowfall and mesoscale banding. Will we get a positive PNA to go along with the negative AL and negative NAO this year, hoping northern PA gets a great winter? I do think we'll start to see that. I do think so. But we have to set up this block first and see how the atmosphere reacts to it first. But I do think we actually do see that. Let's see here. Well, it is 9 o'clock, and I'm starting to lose my voice a little bit. So, I think that's it for tonight. I think we answered a lot of questions. It's definitely going to be interesting the weeks coming ahead. So, my suggestion to you going forward, and let me bring this up here. First of all, again, I want to thank you again for coming in and watching, and it's been great. My advice for you is that if you are doing anything for the holidays, Hanukkah, Christmas, Kwanzaa, whatever, get your presents and whatnot together faster than later. Okay, don't be the last minute shopper, because you might not just be dealing with packed malls and difficult shipping issues, but also winter storms as well. This is probably the most impressive weather pattern I've seen for December in a very long time. Yes, 2009, 2010 would be a good example in terms of potential. But it's certainly been one where there's a lot of potential out there of really driving this pattern. So I would say just be prepared for it. As I said, I don't know the details yet. No one else does either. And expect a lot of model mayhem between now and whenever we start to see these winter storms take place. But I'd be very surprised if we don't exit December with at least one major winter storm impacting the Northeast. So, interesting times are ahead. Thank you again for following and for being in here. And as always, stay safe out there.